There are two engine-driven generators. The generators maintain a constant speed by a drive mechanism known as an integrated drive generator, IDG.
There you have it. Okay.
Each generator supplies alternating current, AC, to its own bus. Generator 1 to AC bus 1, generator 2 to AC bus 2. Each AC bus supplies its own transformer rectifier, TR. AC bus 1 to TR1, AC bus 2 to TR2. The TRs convert alternating current into direct current, DC, to supply their associated DC buses, DC1 and DC2.
Easy so far, huh? We can remember this. If I wake you up at 2 o'clock in the morning, this you can remember.
DC bus 1 then feeds the DC bat bus, DC bat. The DC battery bus can charge the batteries or receive power from the batteries as required. This will be further explained in normal operation. The electrical system also includes two essential buses. The AC essential bus, fed by AC bus 1, the DC essential bus, fed by DC bus 1 via DC bat bus.
So that also means, of course, that the battery can feed also directly the DC essential bus. No generators online. Now your battery is feeding your DC essential bus. Okay? And if you do that long enough, no more power. So
This is the basic electrical system. We will now introduce some other components which supply the basic system. The electrical network can also be supplied by the APU generator. These three generators are all identical, and any one of them can supply the entire aircraft electrical needs.
no IDG on the APU, because APU is turning always at the constant speed, 100%. If you want to shut down the APU, you just give it some false indication that it's turning more than 100%, and the APU will auto shut down. So when you shut down APU, you test at the same time the overspeed on your APU. It's standard in all APUs.
On the ground, the aircraft can be supplied by an external power source. As a backup, there is a hydraulically driven emergency electrical generator, Emergen. The hydraulic power to drive the emergency generator is provided by a ram air turbine, RAT, located in the belly fairing, which extends in case of severe electrical or hydraulic failures.
Also no IDG, because the hydraulic pump is a constant speed pump. So the propeller drives a hydraulic, constant speed hydraulic pump, which drives then again the generator. So we have two things at the same time. We have hydraulic backup and electric backup on your ram air turbine.
The electrical system is also fitted with an essential transformer rectifier, essential TR. The essential TR can power the essential DC bus from the emergency generator in case of severe electrical failure. Note, we will see the emergency generator and the essential TR in detail in the abnormal operation module. Finally, a static inverter allows part of the AC electrical network to be supplied from VAT 1.
See how I just switch everything around? Okay, with the essential TR. If this one is working, nothing else is working, only this one, then via the essential transformer rectifier, we can then feed again the DC bus. No power from this side, no power from this side. So now we take it from here into the DC bus, and again we have power on the essential DC bus, and again we can charge our batteries. If, however, we have no more, AC power, everything fails, then we can take power from this bus, put it inside the inverter, and feed some of the AC power. So we can swap everything around in this airplane. So you must know what's happening, because what does Airbus do? It does everything automatically for you. So sometimes when you have a problem, you say, what the heck is going on? Because it's not really clear to you what is going on with this essential transformer rectifier or the static inverter. Okay. Sometimes it comes online for some reason and you don't know what's going on. It's not like you switch it on or off. So in Airbus, electric problems can sometimes be a headache. You must know your system, and otherwise you will be in trouble.
Now, let's see how this information is presented to the pilots in the cockpit. We will introduce the ECAM electrical page. You can see that most of the components we have talked about are displayed on the ECAM page. Let's briefly review the basic system using the ECAM electrical page. Gen 1 and Gen 2 supplying AC bus 1 and AC bus 2. TR1 and TR2 supplying DC bus 1 and DC bus 2. Two essential buses supplied by the left side. The DC VAT bus and two batteries. Notice that the static inverter is not displayed on the ECAM page. For simplification, the component indications have been removed. Let's now present them. As shown, each component can be monitored via its indications. These indications are voltage, current or load for the generators, frequency, IDG temperature.
So these are the ones, the IDG temperature. When this one starts going up, and you have a problem, you will probably yourself have to remove the whole IDG physically from your engine, not anymore connected to your engine. Okay. If you have IDG over temperature or IDG oil pressure or oil temperature problems, which will show up in the temperature, you have to physically remove the IDG from the engine.
You can also notice the different connections displayed via green lines. Let's now locate the various controls available to the pilots and associate them with the components displayed on the ECAM. The electrical panel is located on the overhead panel. For emergency cases, there is an emergency electrical power panel on the left side of the overhead panel. Now let's look at the relationship between the electrical panel and the ECAM electrical page. The battery voltage can be monitored either on the overhead panel or on the ECAM page. Each battery is controlled by a push-button switch. Both main generators and the APU generator are controlled by their associated push-button switch. The external power is also controlled by a push-button switch. We will learn how to use it in the normal operation modules. The AC essential feed push-button switch enables the pilot to change the feed for the AC essential bus from AC bus 1 to AC bus 2.
Okay, that's clear, huh? If you lose this generator, you would not have any more power to this bus. So if you look on the top, it's the same one here. With this switch, you can now switch this generator to the AC essential bus directly. We can do that, or the airplane does it for you. Okay, which here, of course, is not drawn until you push this button. When you push this button, the line will come from here.
The bus tie push-button switch enables the pilot to isolate one side of the system from the other. You will see and do this in the abnormal operation modules. In case of failure, these push-button switches enable you to disconnect an IDG from its drive shaft. The controls and indications on the emergency electrical power panel will be covered in the abnormal operation modules. There is one exception. The emergency generator test switch is used by maintenance only to test the emergency generator. In this module, you have seen the electrical configuration on ground, with both engines running and with APU generator and external power available. We will introduce the different possible configurations in the next modules.
Okay, so you see that everything you learn